Hello everyone. In our video today we're going to take a look at an example of calculating whether a function is increasing or not on some interval using calculus, of course, and some partial fractions. Okay, so here's the example we're going to take a look at. F of x is 2x plus 2 divided by x squared, take away 2x, take away 3, and just for fun we can add on another term, which is x plus 1 divided by x take away 3. Okay, so the first question, express this function as a single fraction. And part B, show that the derivative is equal to 2 divided by x take away 3 all squared. Hence, f is an increasing function. And the reason why it's increasing is that the function is always bigger than 0, and we should say up here somewhere x cannot be equal to 3 because we're dividing by 0. Okay, and it's always bigger than 0 because the bottom of the fraction is always non-negative, and so when we divide we never get a negative number. Okay, so let's do it straight in. Solution to part A. So actually I don't think we're going to need the partial fractions too much. We need some cross multiplying. So the function f, we're going to write this as 2x plus 2. We're going to factorize the bottom. Okay, and over on the right hand side, the second term, there's not much we can do with this. Okay, so what are the factors of the quadratic here? We have an x and an x. So let's see, a 3 and a 1. Signs need to be different. There's a minus 2, so this is a minus and a plus. Okay, so we want a common denominator. We have an x minus 3 factor in both already, and an x plus 1 here, so we should build an x plus 1 in the second term, like so. Okay, so now we've got a common denominator, and we should be really careful here. X cannot be minus 1, otherwise the whole thing explodes. We end up dividing by 0, we end up with some singularity. Okay, so now we've got a common denominator, we're ready to collect everything together. Let's do that on a clean page. So our function, so because the bottoms are the same, we can just collect the top. So what was that? I think that's a plus 1, and this is all divided by x plus 1, x plus 3. Okay, let's just check that that's right. Is our question? Yeah, that looks good. Okay, so the top, what's the best way to do this? Well, we need to find factors in here that are also over here, or we could just times it all out and power through. Actually, there's an x plus 1 in both. we can see that if we take it out like this, and now if there's this common factor here and here, makes the calculation so much easier. So we take that out, we have 2, take away x plus 1, the bottom stays the same, which is the same as, what do we have here? As we have minus x minus 1, so minus x, if I take off 1, just from 2 I have 1, all divided by x plus 1, x plus 3. Okay, x cannot be minus 1, we've already highlighted that, so I can cancel these off, and we're left with the function. Okay, I don't like to see the negative on the x. Normally we change it to a positive, and we bring in a negative at the front. So we end up with minus a negative fraction with x minus 1 on top, x plus 3 on the bottom. So there you go. So that is part A. A bit of work, but we got there. This is the function written as a single fraction. Okay, let's take a deep breath before we look at B. Part B, we need to differentiate this and show that it's never negative, it's non-negative. So let's start a clean page. Let's just remind ourselves on this clean page for part B, our function is minus x plus 1 all divided by x take away 3, which is the same as 1 take away x, x take away 3, and we need to find the derivative. Okay, so what do we do when we want to differentiate a fraction? Well, we need the quotient rule. So let's do it. The quotient rule. So we differentiate the top. Well, maybe I'll highlight this a bit better. So this is the quotient rule. We label something f, something g, or maybe some people like maybe u or v. Maybe u and v is better. I don't want to clash with the f I've already used. So the quotient rule says differentiate u with respect to x, keep v the same, subtract, keep u the same, and differentiate v, all divided by v squared. Okay, there's some slight variations to that. That's the way I do it. Works for me. Now I want to simplify. So let's times out the bracket. It's a bit messy in here, so I think I'm just going to times it all out, make it a bit neater. So we have minus x plus 3, minus 1 plus x. The bottom stays the same. And oh, we're very fortunate here. The x's cancel, leaving just a constant, which is just 2. And on the bottom, that doesn't change, x take away 3 all squared. So our derivative f dash x is 2 divided by x take away 3 all squared, which is bigger than 0 for all our values, which was all x except for 3, and the other one was minus 1. So it's increasing for all values that we considered. It's increasing for all x except x equal to 3 and minus 1. where it's not defined. And there you go, that finishes off that example.